Integration of sine and cos is very similar to using the chain rule. We're almost always looking at integration by substitution when we do this. Now, you don't have to think of it that way. I just think that it's easier. Um, First thing we need to remember is the derivative of sine is cos, and the derivative of cos is negative sine. And so then when we're taking the integrals, it's just the opposite. The integral of sine is going to be negative cos because we're looking at this value. Okay. The integral of cos is going to be sine because we're going in reverse from here. Okay, so it's kind of the opposite of what we were thinking about before. The integrals of these functions, so we've then got these kind of rules right here where we've got, and it's very, very similar to what we had before. We're just adding the negatives and positives in where they apply. So 1 over a would be if we just had a value inside there, or here it's just going to be positive because it's now the negative of what we had before. And then we can use our integration by substitution when we're using something like this. Okay, now most of the time it's going to be integration by substitution just because of the way that sine and cos are set up. However, it's not always the case. So let's look at some examples. So the first one here, what we can recognize for this first one is we can actually just, sorry, I'm going to just make this a little thinner. We can break this up into two integrals. So we can have the integral of 3 sine x plus the integral of 2 cos x. And then we can bring our coefficients in front. And then we can just do straight integration with this one. So we're just going to have the integral of 3 sine x is going to be negative 3 cos x plus, and then this is going to be 2 sine x, and then we always have to add our constant in at the end. Okay, and these were all dx. There we go. So when you're looking at that, you can always break those up, and we're differentiating with respect to x. All right, so moving on to the next one. This one is just that law that we had right in the middle here, where we're looking at the 1 over a value. Okay, and you should get pretty comfortable with using all of those rules. You don't have to do much else with this one. You're going to have 1 over a, so it's going to be 1 over 2. And then all we're doing is the integral of cos, which is positive sine, and then 2x plus 5. And we're done. So that one is pretty easy. Don't forget to add your constant in at the end because we're not doing definite, we're indefinite still right now. Okay, I'm going to just move that away. This one is actually integration. Both of the next two are actually integration by substitution. So what we're going to do is let u equal e to the x, and then du by dx is e to the x. So dx is equal to e to the negative x, or du over e to the x. So I'm going to just write it like this. So then when we substitute in, we're going to get um, this. And if you remember back to our integration by substitution, everything should kind of cancel out like that. So you've got a nice integration to do, which is just going to be sine u, and then plus c, which is going to be sine e to the x plus c. Okay, when you're going through this, This value, when I substitute it in, is going to cancel out that, and we're substituting in for this. So we're going to be adding the du at the end, and it's going to cancel out the e to the x. Okay. Now, same thing over here. We're going to move into integration by substitution again. Okay, so we're going to have, and I'll write it, I guess I'll write it right here. So this time, when we're doing this, we're always using this value. Okay, so we're going to have u is 3 to the x to the 4. So then du by dx is going to be 12x cubed. And then when we solve for dx, we're going to get 1 over 12x cubed. Okay, and that's du. So that's going to cancel that out, but we're going to have the 1 over 12 on the bottom. So when we substitute all that in, we're going to get our we're going to have 1 over 12 first, because we can always bring that coefficient in front. And we're going to have cos u du. We get 1 over 12 sine u plus c. And then we just substitute in 1 over 12 sine 3x cubed, or sorry, 3x to the 4 plus c. All right. So just going back over all your integration laws here. Next. Okay, these ones are the same. We're always going from the top minus the bottom, and when we want to find it, we need to substitute in. Okay, so when we're looking at this one, we're going to have equals. So first thing we want to do is integrate. So we're going to get this is equal to 2 sine x plus c. And then we're going to integrate. We're going to do pi by 6 minus 0. Okay, so then when we're simplifying this, we're going to have 2 sine pi by 6 plus c minus 2. Oh, I should sine 0 plus c. Now, sine of pi by 6 is going to be 1/2. And then we have plus c. I'm just writing all this out. You wouldn't have to write this last step. You can kind of just go right to the answer, which is 1 minus 2 times 0 plus c. So our c's will cancel out. 0 is 0. 2 times 1/2 is 1. Okay, I'm just substituting in and subtracting. Okay, so here, this one's a little bit more difficult just because of that second integration. It's actually not that hard. So what we could do is you could change this into 2 integrations if you really want to. For this second one, I mean, it's just 1 over 2. If you didn't see it, you could do integration by substitution, but it's not a difficult integration. So what we'll do is we'll just write out our solution first. So we'll have the integration is going to be what? -2. I'm going to put the -2 cos x at the end, just so that's the integral of this. Because the other one's going to be positive, I think it's just going to look, I guess the other one's going to be -2, so it doesn't really matter. Why don't we put that one at the front? They're both going to be negative. So we're going to have negative 2 cos x at the front plus, or sorry, minus, because it's going to end up being minus because of the cos is going to be negative when we do the integral of sine. So minus a half and then cos 2x. And we're going from pi by 2 to pi by 4. So we're going to be subtracting all of this. So negative 2 cos of pi by 2 minus a half cos 2 pi by 2 minus, now we're going to do all of that again. Oh, we're running out of space here. So we're going to write it real small. All right. Now then when you simplify all that down, I'm going to actually let you guys go through that. This is good practice for like pi by 2. Remember, I did this on the board before, but we've got 0, pi by 2, pi, 3 pi by 2, and 2 pi. And remember, cos is always your x, sine is always your y. And this is obviously 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, now I want you guys to go through and try to simplify that, and we will take it up later. Okay, after you're done, there are the questions